Okay, this is a video that's going to teach you how to solve linear systems by elimination. If you're watching this in my class, please understand that I do expect you to take notes, and I will be checking homework tomorrow, which is page 18. Write that down right now. When I check page 18, I will be checking to see if you wrote down the notes I'm giving in this video. So please make sure you take care of that. If you are on my remind.com list, I will be sending out a text with a link to this YouTube video so you can fill in any gaps you have later. The link will also be listed in the Remind area on the Edline page. So if you don't get the Remind messages, if you just log into Edline and go to the Algebra 1 Edline page, it will list the video link and have the notes will be where class notes normally are put. So far we have solved linear systems with substitution. Yesterday we set equations equal to each other. We put them into our calculator. We looked at the tables. We've made graphs and found the ordered pairs. Today we're going to use a method called elimination. So what I want you to do, again, please write down homework tonight is page 18. Open up your packet to page 15. And using the pictures below on page 15, let's see if we can solve this word problem to find out how much each cheeseburger and soda costs. So Monique bought 2 cheeseburgers and 1 large soda. She spent $7. Scott bought 4 cheeseburgers and 1 large soda, and he spent $12. It says, use the pictures to determine the cost of each. So here we go. So first off, the first thing I'm going to notice is that they both bought 1 drink. So I'm going to cross those off. Those are the same. Okay. And I also noticed that they bought 2 hamburgers. So I'll cross those off. So if they both bought 2 hamburgers and a soda, and remember this is Monique, if she spent $7, that must mean that 2 hamburgers, well, if I take off 2 hamburgers and a soda, that means that just these 2 hamburgers would be 12 minus 7, because if I took off the 2 hamburgers and the soda, I got to also take off the $7. And 12 minus 7, as you know, is 5. And that means that each burger, if 2 burgers are $5, that means that 1 burger equals $2.50. So now we can think, okay, if 2 burgers are $5, 1 burger is $2.50, we can go back over here. These 2 burgers together cost $5. So that must mean that the soda cost $2. This method that we just used with these pictures is called elimination, because what we did is we eliminated Scott's order from Monique's order, and we were able to come up with the idea that 2 hamburgers only cost $5. So let's take a look at the next picture example. It says use the pictures below to determine the cost of each hat and umbrella. So we see the first one is umbrella plus hat plus umbrella is $32, and the second one is umbrella plus hat is $20. So we know that 1 umbrella and 1 hat is $20. So if I eliminate 1 umbrella and 1 hat from each line, because I know that this is $20, I know that the 1 umbrella left must be 12, which makes the hat, because then I go back here and I say, all right, well, this is 12 for this umbrella, so 12 plus the hat is 20. That means the hat must equal $8. Okay, again, this picture example is called elimination. So go ahead and flip the page, go to page 16. So the purpose of elimination is to eliminate or cancel out one of the variables. Now what I want you to notice is that all the problems here are going to be written in standard form. Standard form is ax plus by equals c. And really what you want to notice is that everything lines up. There are the x's, there are the y's, the equal signs, and the constant. So on page 16, I'm not going to follow these examples exactly for steps for elimination. What I'm going to do is, you can use them if you need to, but I'm going to loosely follow them. So the first thing we are going to do is decide what variable we are going to eliminate. And the way we're going to decide is we're going to look to see which coefficients are the closest. So we've got 5 and -2, and then we've got 2 and 2. And when I mean the closest, I really mean the same. So 2 and 2 are the same. Our goal is to add the two equations together. We're always going to, everybody write this down, add down to eliminate. And there's my abbreviation for you. You know I do like a good abbreviation. Don't write this part down yet. Now if I add down right now, 5x minus 2x, add those down, I get 3x. 2y plus 2y would give me 4y. Nothing eliminated here. I still have an x and I still have a y. So this is what I want you to do. We are going to change the sign of everything in the second equation. So I'm going to do this in a thicker pen in purple. So this minus 2, everybody make that a plus 2. This minus 2y, this positive 2y rather, we're all going to make it a negative 2y. Negative 14 is going to become positive 14. Now we are going to add down to eliminate. Watch what happens. Everybody put a line underneath. When we add down, 5x plus 2x is 7x. 2y minus 2y becomes 0y. Yay, they're gone. You don't even need that. You can scratch it out if you wrote in pen. All right, so these are gone. They're gone. They eliminated. 7 plus 14 is 21. Guess what? We're almost done. If we know 7x is 21, we can divide by 7 and get x equals 3. Hooray! Now we need to know what y is. So I'm going to go back to either equation. I'm actually going to go back to the first equation. It really does not matter. You can go back to either equation you like. I'm going to pick up x equals 3. Everybody circle it. And we're going to put it right where the x was here. So everyone is going to write 5 times 3, because it's 5x and we know x is 3, plus 2y equals 7. Ooh, leaky pen. All right, so now 5 times 3 is 15. And I bet some people are already working ahead. You know who you are. I'm looking at you through the Promethean board. We're going to subtract 15. 7 minus 15 is negative 8. 2y equals negative 8. And I'm going to divide by 2. And I'm running out of room here, I get y equals negative 4. So I know my ordered pair is going to be, it says make sure, remember your answer should be in an ordered pair, should be 3, negative 4. So what I'm going to do is I'm just going to kind of go down these and show you how we really did follow these. I don't eliminate them by subtracting. We are always going to add down. If that means we have to change all the signs, we're going to change all the signs. We are going to add together or subtract, because you know here it was like subtracting, the entire equations together to get one single equation. One of the variables should have canceled. So right here we had 7x equals 21. We solved for the remaining variable. Then we plugged that in. And then we wrote our answer in an ordered pair. Let's take a look at the first problem. Okay, so when I look at these, when I look at number, I feel like I'm missing some problems. I feel like you will have more. Are they hiding? I feel like we're missing some problems, guys. Hold on, let me see if I can find them. I don't know where they went, so we'll just continue without it. So if you have 1, 2, and 3 on your paper, you'll just have a little extra space. So problem number 4 says 3x plus 2y equals negative 1. And underneath that, it says 4x plus 2y equals negative 6. What we're going to do is we're going to, again, examine the coefficients. Here we've got 3 and 4. Those are not the same. Here we've got 2 and 2. Those are the same. Here we've got negative 1 and negative 6. Who cares? What I know is I've got 2y and 2y. and they're both positive. Again, just like the example, if I add down right now, they will not eliminate. I need to change the signs. Because the numbers are smaller in the top equation, I'm going to change the signs of the top equation. It does not matter as long as 1, 2 ends up positive and 1, 2 ends up negative. Alright, sorry about that. One of my little patients needed me. Alright, so again, I know you guys have 1, 2, and 3, but I don't, so we'll just do 3, and that will probably be good, and then we'll move on to the next page. So, before I attend to my little patient, we changed the signs on the first equation of number 4 so that the -2 and the +2 would eliminate. So let's go ahead and add down. -3 plus 4 is 1x. -2 plus 2, they eliminate. 1 minus 6 is -5. Now this one's kind of nice because you don't really need to, but I know some of you like to. So if you want to divide by 1, you end up with x equals -5. And what you're going to do with that -5 is you're going to pick it up and you're going to put it back into one of the original equations. It doesn't matter which one. Whatever one you like, whatever one you think has smaller numbers. I'm going to erase this just to clean it up a little bit. And so when I look at these, I think I would rather work with the first equation because the first equation has smaller numbers. So I'll go with that one. So I'm going to say 3 times -5 plus 2y equals -1. 3 times -5 is -15 plus 2y equals -1. I'm going to add 15 to both sides. And again, you can use the area above it because I don't know what happened to my problems. I get 2y equals 14. I'll divide by 2, and I get y equals 7. And that makes the ordered pair for this problem -5, 7. Let's take a look at number 5. This is an interesting problem. When I look at number 5, I notice that I've got 7 and 7, and +2 and -2. Now I could change all of the signs so that 1 7 would be a plus and 1 7 would be a minus. But look at the y's. I already have +2 and -2. Look what happens if you add down right away. Everybody go ahead and do that. 7x plus 7x is 14x. +2 and -2 cancel out. 2 minus 30 is -28. We'll divide both sides by 14 to get x equals -2. Again, it does not matter where you put the -2. Now, when I look at these equations, I'm looking for the one that looks easier. So think to yourself for a second, what looks easier, the first equation or the second equation? I think the first equation looks easier, and here's why. When I look at these, there are no negative numbers here, and I don't like negative numbers. They cause us to have errors. So I'm going to put this -2 right here. So I'm going to say 7 times -2 plus 2y equals 2. 7 times -2 is -14 plus 2y equals 2. I'm going to add 14 to both sides. Ooh, that was, ooh, uh-oh, oh no. Oh, no, 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 hold on. I have a leaky pen. Oh, crap. So that's going to be, I'm going to have to type for a minute. Oh, that's terrible. There we go. We get 2y equals 16. And if we divide both sides by 2, we would get y equals 8. And that gives us the ordered pair -2, 8. I want everyone to examine the structure of number 6. I want you to look very carefully at the coefficients. Let's see if we can get the pen happy again. Okay, so I see the x's are 3 and 3, and I see the y's are -9 and -15. These are not the same, so I'm not going to mess with these. But here we have 3 and 3. One of them needs to be made negative. Now, because they're both positive, it really does not matter which one you want to make negative. Just to make life a little easier, I'm going to make the second one, I'm going to change all the signs for the second equation. So I'm going to make it -3 plus 15 plus 6. You totally could have done the first one. It's not really a big deal. Now I'm going to add down. 3x minus 3x becomes 0. 9 plus 15 becomes 6y. -9, sorry. -9 plus 15 becomes 6y. -12 plus 6 becomes -6. I'm going to divide, and I get y equals -1. Again, I'm going to plug that back in to either the first equation or the second equation. Now, I don't really know that either one of these is any easier than the other. I look at this, I got a -9 and -15. This is a -12 and this is a -6. So just for ease, I'm going to put it into the first equation because I'm having pen problems. I think I'm going to type it just to be sure. So here we go. I'm going to put it in the first equation. I've got 3x minus 9, and now instead of the y, I'm going to put -1 equals -12. Well, that becomes 3x, -9 times -1 becomes +9 equals -12. If I subtract 9 from both sides, I'll get 3x equals -21. Divide both sides by 3, I get x equals -7. So this makes my ordered pair -7, -1, x comma y. So what I would like everyone to do when you're done writing this down is please turn your desks into your groups and work on the next page. Slowly, I'm going to let the video run. I'm going to add all the answers into the next page and have the sub pause the video so you can check your answers as you go. Your homework again is page 18. Now it's hard to see, so I'll just write it in. Okay, so for the word problem, it says to write this system of linear inequality. So first off, I'm just going to type right over this, and then I'll put the answers in so you can check your equations. 2 hamburgers. Let's move all this up. Can I move all of this up so you can see everything at once? Would it? No. All right, so I'm going to put the equations in here again. You should be working in your groups and not really listening to this. All right, so here you go. Here are your answers. Pause the video before it ends so you can check as you go.